losing heat to the side, but have a think about where else we're losing heat as well. Think about how we could improve this experiment. Yes. What temperature? It's okay. Well, tell me why. So methanol, what was the difference of methanol and butanol? It's smaller. So maybe it takes longer with methanol from a fuel.
It should be able to burn long, burn powerful, and to release lots of energy.
So you want a fuel to release lots of energy. If you want to use a lot of that fuel and get a lot of energy for a large amount of fuel?
Generally, you want to be able to use a little bit of fuel to get maximum results.
And what do you mean by results?
You want to have as much as, for example, if you're trying to evaporate something, burn something, be able to burn that item with a little bit of fuel.
Okay, what keyword am I looking for? What do we get from that fuel when we burn it? You've already said it.
Results.
What results? What do we get from burning a fuel? And we have 9 different types of it. Heat.
Energy.
Energy, well done, yeah, exactly. So methanol, ethanol, and butanol, the 3 fuels that we're burning, which one do you predict would give us the most energy from the smallest amount?
Right now, as per our results, butanol.
Very good. Why do you think butanol?
It reached 64 degrees with us only using 1.07 or something.
Nice. So you're using your evidence to form that conclusion. That's really good. What about the size of the molecule? So do you remember when I showed you there was methanol that was 1 carbon, ethanol 2 carbons, then propanol, which was 3, and then butanol that was 4. So how do you think the size of the molecule could affect the energy we get from it?
Since it's larger, it probably uses less of one type of molecule and more of one. So.
Yeah, water. And we'll just do it as a word equation. Sodium plus water. A nice arrow to show our reaction occurring. Think about that as chemical product. So we wouldn't write flames here. What would we write, Denise?
Hydrogen.
So hydrogen. And what else? What type of hydroxide? And what was the metal? There you go. So I want you to just follow that line of thinking that means we're on one side and we've got hydrogen, sodium and oxygen on the other side. Nothing added, nothing taken away, they're all there. Now, consider what we did first. We did lithium first. Can you write the equation for the reaction of lithium and water? So you've got an equation and a word equation. Reaction of lithium and water.
Human to fill that space. Anything with a charge needs a protein to allow it to move from the inside to the outside of the cell. That protein, the structure, will be very, very highly specific, and every single protein in your body comes from a gene. And every single genetic disease is from a protein that doesn't have the right shape. So as you put in more of the green can move through. Is this process involving any energy from respiration? It won't diffuse by itself. It needs to have a protein, and that's why it's facilitated. It's helping it out. Without it, it won't happen.
I got one. Wait, then what's the point of this one if it doesn't move?
You're supposed to open it up.
Wait, then what's the point of this one if you can open it up here?
No one's always no one's sometimes.
Argon has a full outer shell of electrons. True or false?
True.
Of course it's true. Argon is very reactive and used in lamps.
False.
Well, we just saw that it was used in lamps.
False.
Why is it used in lamps? Because it's unreactive, not because it's reactive. So which one?
Right, okay. 3, 2, 1. Hold up your answers. Hayden. Right, so your shape, everyone's got bent or V shape. You can also have non-linear. Your angles, most of you have got right. Bonding pairs, 2 bonding pairs, 2 lone pairs. That's going to reduce your angle by 5 compared to like a tetrahedral, which is why it's 104.5, because you've got more repulsion between the lone pairs. So, can you do the VESPA notation for this one and tell me the angle and the shape, please? What is the example of the molecule for this one?
I just stared in the
Let's go. 20 seconds. Pyramidal. What do you need for pyramidal? Lone pair. This one does not have a lone pair, so what does this make it? It makes it trigonal planar with 120. It's got 3 bonding pairs, no lone pairs. This one, octahedral, you've got like a square planar in the middle, 1 top, 1 bottom. And for this one, make sure your wedge is not directly down, it's a little bit to the right. Right, so your wedge needs to just be slightly at an angle. Good. Good, good.